It's time for landing now. When you board a plane, you might not think about how it's going to land. It's easy to take for granted that the pilot will safely guide the aircraft to the ground. However, landing a plane is a complex process that requires precision and skill. In this article, we'll explore how planes land and what goes into make a safe landing. To begin, it's important to understand that landing a plane is not just a matter of pointing the nose downward and touching the wheels to the ground. Pilots must consider a variety of factors, including wind speed and direction, runway length and condition, and the weight and speed of the aircraft. They must follow specific procedures and protocols to ensure a safe landing. We'll delve into these factors and procedures in more detail in the following sections. Overall, understanding how planes land can give you a greater appreciation for the skill and expertise of pilots. It can also help ease any fears or anxieties you may have about flying. So, let's take a closer look at the process of landing a plane and what it takes to do it safely. Understanding flight mechanics. When a plane is in the air, it is subject to four main forces, which are lift, weight, thrust, and drag. Understanding these forces is key to understanding how planes land. Role of wings. The wings of a plane are designed to create lift. Lift is the force that keeps the plane in the air. The shape of the wings, as well as the speed of the plane, determines the amount of lift generated. When a plane is coming in for a landing, the pilot will adjust the angle of the wings to decrease lift and begin the descent. Role of engines. The engines of a plane provide thrust, which is the force that propels the plane forward. During landing, the pilot will reduce the amount of thrust to slow the plane down and prepare for touchdown. It is important for the pilot to maintain a certain speed during landing to ensure a safe touchdown. In addition to lift and thrust, drag and weight also play a role in landing. Drag is the force that opposes the motion of the plane, while weight is the force of gravity pulling the plane down. The pilot must balance these forces to ensure a smooth landing. Overall, understanding the role of lift, thrust, drag, and weight is essential to understanding how planes land. By carefully controlling these forces, pilots are able to safely bring planes back to the ground. The landing process. When a plane approaches its destination airport, the landing process begins. This process is broken down into three main phases: approach, touchdown, and deceleration. First is approach. During the approach phase, the pilot begins to descend the plane towards the runway. The pilot must ensure that the plane is at the correct altitude, speed, and angle of descent. This is achieved by using a combination of instruments and visual cues, such as the runway lights and the plane's altimeter. Touchdown. Phase 2. Once the plane is aligned with the runway, the pilot will begin the touchdown phase. The goal of this phase is to safely land the plane on the runway. The pilot will reduce the plane's speed and altitude until the wheels touch on the ground. The touchdown phase is crucial as it determines whether the landing is successful or not. Deceleration. After the wheels touch the ground, the pilot will engage the plane's brakes and reverse thrusters to slow down the plane. This is known as the deceleration phase. The pilot must carefully control the deceleration to ensure that the plane comes to a complete stop before reaching the end of the runway. Factors affecting landing. When it comes to landing a plane, there are several factors that can affect the process. Here are three main factors that pilots need to consider. Weather conditions. Weather conditions play a crucial role in the landing process. Pilots need to take into account the wind speed and direction, visibility and precipitation. Crosswinds can make it difficult to maintain the correct approach angle, while low visibility can make it hard to see the runway. In extreme weather conditions, such as heavy rain or snow, pilots may need to divert to another airport or delay the landing. Runway length. The length of the runway is another important factor to consider when landing a plane. The longer the runway, the more time the pilot has to slow down and bring the plane to a stop. If the runway is too short, they may need to use the reverse thrust or brakes to slow down the plane, which can put a strain on the landing gear. Weight of the plane. The weight of the plane also affects the landing process. Heavier planes require more runway to come to a stop, and the pilots need to adjust the approach and speed accordingly. The weight of the plane also affects the angle of descent and the amount of lift needed to keep the plane in the air. In some cases, the pilot may need to dump fuel before landing to reduce the weight of the plane. Use of landing gears. Safety measures during landing. When a plane lands, there are several safety measures that are put in place to ensure a smooth and safe landing. These measures include the use of landing gears and the role of air traffic control. Use of landing gears. Landing gears are an essential part of the landing process. They are the wheels and struts that support the plane during takeoff and landing. The landing gears are designed to absorb the shock of landing and keep the plane stable during the process. Before landing, the pilot will extend the landing gears to ensure the plane is ready for a safe landing. Once the landing gears are extended, the pilot will lower the plane's speed and altitude to prepare for the landing. Role of air traffic control. Air traffic control plays a crucial role in ensuring the safety of planes during landing. Air traffic controllers are responsible for directing planes to the correct runway and ensuring that they are at a safe altitude and speed. During the process, air traffic controllers communicate with the pilot to provide guidance and ensure that the plane is on the correct approach path. They also monitor the weather conditions and runway conditions to ensure the landing is safe. In addition, they are responsible for coordinating with other planes in the area to ensure that there is no interference during the landing process. Now, one more part of the landing part. Our final part of landing is called, what is a hard landing? A hard landing occurs when an aircraft touches the runway with greater vertical speed and force than its typical or desirable. This can happen due to factors like pilot error, strong winds, or mechanical issues. A hard landing in aviation refers to a landing maneuver in which an aircraft makes contact with the runway surfaces with greater vertical speed and force than its typical or desirable for a smooth and controlled touchdown. This occurrence can result from a combination of factors, including pilot's errors, adverse weather conditions, mechanical issues, or a combination thereof. Unlike a normal landing where the aircraft settles gently onto the runway with minimal impact, a hard landing may be characterized by a sudden jolt, excessive bounce, or audible impact upon touchdown. Key characteristics. Number 1. Excessive vertical speed. Hard landings often involve a higher rate of descent or vertical speed at the moment of touchdown than what is considered optimal for a smooth and controlled landing. This increased descent rate can result in a harder impact on the runway surface, leading to passenger discomfort and potential damage to the aircraft structure. Number 2. Increased impact force. A hard landing typically generates greater impact forces between the aircraft's landing gear and the runway surface due to the higher vertical speed of touchdown. These forces can exceed the design limits of the landing gear and airframe, potentially causing structural damage or component stress. Number 3. Audible impact. In some cases, a hard landing may be accompanied by audible cues such as a loud thud, bang, or squeal as the aircraft makes contact with the runway. These sounds may indicate excessive force or stress on the aircraft's landing gear components or structural elements. And number 4, potential bounce. Following a hard landing, the aircraft may experience a bounce or rebound effect as it rebounds off the runway surface due to an excess energy absorbed during the initial touchdown. Bounces can prove... Oh, hold on a second. There we go. Oh, there we are. My battery's about to die then, but I'm charging it now, which is good. Anyway, following a hard landing, the aircraft may experience a bounce or rebound effect as it rebounds off the runway surface due to the excess energy absorbed during the initial touchdown. Bounces can prolong the landing rollout and increase the risk of additional stress on the landing gear or airframe. The causes of hard landings. Pilot error. Misjudgment of approach speed, altitude or descent rate, improper flare technique, or failure to arrest the descent during the landing flare are common causes of hard landing and attributable to pilot error. And number 2, adverse weather conditions. Strong crosswinds, gusty winds, wind shear or turbulent air can contribute to challenging landing conditions and increase the likelihood of a hard landing if not adequately compensated for by the pilot. Mechanical issues. Malfunctions or failures of aircraft systems such as a malfunctioning landing gear, hydraulic system failures or brake issues can lead to hard landings if not addressed promptly or mitigated through proper procedures. Now remember this now. A hard landing in aviation refers to a landing maneuver characterized by excessive vertical speed and impact forces upon touchdown, often resulting from pilot error, adverse weather conditions or mechanical issues. While hard landings can cause discomfort for passengers and potential damage to the aircraft, proactive measures such as pilot training, weather monitoring, aircraft maintenance and flight crew coordination can help prevent and mitigate the risk of hard landings, ensuring the safety and discomfort of flight operations. As such, continuous vigilance, proficiency and adherence to established procedures are essential for promoting safe and smooth landings in aviation. That's all for today. See you soon. Bye.